Yeah, so I'm gonna record this so that I'll post it somewhere later. But first thing you want to do, make sure that you have Ganache installed, because this is how we're gonna work with the Ethereum blockchain locally. And I'll post a link to this in the chat for you. But yeah, this just lets us work with the EVM network locally. That way we don't have to spend actual Ether or any of that precious crypto. I haven't tried this with Remix, so I'm not sure if
you should be able to use Remix.
Yeah.
When I've written it with Solidity before, we used Remix and it worked really well.
Okay.
Yeah.
Cool. Good to know. So yeah, you can use Remix if you don't want to install anything locally. But with that being said, let me try switching over to VS Code now. All right, can y'all see this incredibly messy terminal? So the reason I have this up showing like this is basically because we're gonna wrap our Dapp in a Redwood app. Oh my gosh, wrap our Dapp in a Redwood app. Yes, that's what we're doing today. So I thought about just running that command while y'all were here, but it takes a few minutes and I didn't want y'all to watch these logs for 5 minutes. So this is the command you'll need to run, is this yarn create Redwood app Cascadia Dapp. And I'll also post this in the chat if you're following along. And this just generates a fresh Redwood app for you. So I'm gonna go ahead and open that. Where did I put that? There
what is Redwood for anyone that doesn't know?
Oh, so Redwood is actually this cool like full stack Jamstack framework that's kind of like Next, except better in my opinion, just because it uses GraphQL for the backend, and the way that it handles the web directory is a little opinionated, but it still gives you more flexibility than like Next making you use a certain folder structure. But that's just my little 2 cents. Basically though, Redwood is a full stack Jamstack framework.
Nice.
Any other questions so far? All right, that's no big deal. Really didn't expect a whole lot of questions because we haven't done much, right? So let me make sure I'm not missing anybody in the waiting room. And thank you, Daniel, for posting that link to Redwood. So we have our Redwood app set up, and maybe I should just share my desktop. That'll probably be easier at this point. But we have the Redwood app set up, and if you are using Ganache, this is kind of what it will look like when you first started. So I'm not gonna cheat and leave that open. I'm gonna start a fresh instance and we can all see what happens when I get ready to deploy to this network. But if you are following along, make sure you open Ganache, and then you'll just do quick start Ethereum, and this sparks up a whole network for you right there on your local machine. All right, so we got Ganache set up. The next thing we're gonna do is go ahead and add a couple of things to our Redwood app. So we're going, can y'all see the terminal okay, or should I, is that better? Okay, I'm gonna go with bigger is probably better in this case. All right, so we got our terminal up, and what we're gonna run now, we're gonna go to the web directory, because this is where we're going to set up our smart contracts. There's not really a rule or a strict reason I'm doing this in the web directory versus the API directory, which now I think I should explain that. With Redwood, it generated all of these files for us. So we have a fully functional front end and back end in this directory. The API folder, we have the stuff that handles our database connections, and we have the like GraphQL types and resolvers. And then in the web directory, we have like our pages, any components and layouts that we want to work with. And I put the smart contracts in the web directory just because I'm thinking about the Dapp. You don't necessarily have to have any particular backend for a distributed app because the blockchain is your backend. So that's kind of like my logic for putting that in the web directory. But here we're gonna add a couple of packages. So we're gonna be working with Truffle to handle our smart contract migrations and any interactions we need to do with the network, like getting our address, which is going to be super important. And then we'll add the Web3 package so that we can interact with the blockchain just from our React front end. So any questions about the tools so far?
Yeah, I had a question about, it was mentioned a second ago, Remix. What's that and why are we choosing Ganache over Remix?
So Remix, I'm actually not very familiar with. I just know that it came up in the chat. And Ganache, the only reason that I'm using it is because we can see some of the events that happen. So when we add a block to the chain, you can actually see, oh, block number 35 has been added. It's just a good local validation.
It's like Code Sandbox, you know. It's like a virtual remote way to execute code and when you're working with these contracts. So just think of it like Code Sandbox.
Okay.
Cool. That makes sense.
And just taking a second to look at the chat here. So James, you asked if there was anything we need to set up. The main thing right now is just going to be Ganache, which you can download. I posted it earlier in the chat. So it's up there with the Truffle suite. You can download that, and then all we've done is set up a new Redwood app, and there's the yarn command up a little bit earlier in the chat for that. And then Brian, that command that I ran after CD web, I just posted that in the chat.
Thank you.
No problem. Any other questions so far while we're waiting for these packages that I didn't think would take this long to install? Oh, okay. It didn't take quite as long as I thought it would. Sweet. Got a couple new people. Welcome. We haven't done a whole lot. You can catch up with the stuff that we need to get started in the chat. And yeah, so from here, what I'm gonna do is actually make our first smart contract. We're gonna do this with the truffle command and a toggle of my node version, just because I have my environment set up a little janky. But don't we all have some weirdness in our local environments? But I digress. We're going to run truffle init. And what this does is set up a couple of new directories in this web folder. We have this contracts directory now, which has this migrations smart contract. So we have our first official smart contract here. And all this does is very basic smart contract. We always start off by defining the version of Solidity that we're going to work with. And then we jump into actually creating the smart contract. There's not a link to the code in Discord yet. Sorry, I'll post a link to this repo after the workshop though. But yeah, we've defined our version of Solidity, and now we're just getting into our smart contract definition. And Solidity is kind of like a weird mix of JavaScript and maybe C++, because we still have this kind of object syntax, but we definitely have stronger type and scope definitions. But what we have here first is a type of address, which just defines the address of a contract or a user on the blockchain. And we are setting this to have public access, which means that anyone who connects to this smart contract can see the address of the owner. And we get that from the message sender, which is set whenever we deploy a smart contract or we connect to a smart contract. Then we have an integer that's also public that tells us when the last migration was completed or what that was. And if we did need to have some kind of restricted access to different functions with our smart contracts or across any cluster of smart contracts, we have this restricted modifier. So if you are not the owner of this contract, then you won't be able to execute any functions that have this restricted modifier. So any questions on this so far? This was just a boilerplate smart contract generated by Truffle.
Is contract a feature of the Solidity language, or is that something that refers to a feature of the blockchain?
Contract is a feature of the Solidity language. There's a couple of other languages like Viper and the other ones is that they escape me right now, but Solidity and Viper are the main two.
And then what's the difference? What's a contract versus a smart contract? Or is there
So
something I'm missing
that's just some terminology. Good questions. But a smart contract is basically just some code that's stored on the blockchain, and then it's run whenever a condition is met. So in some cases, that'll be a user making a call to a function that's in the blockchain. The smart contract is just how we get those functions on the blockchain for people to access.
Gotcha. Thank you.
Sweet, no problem. But I don't think there's any regular contracts. There's just one of those syntax things that who knows why, except the people who wrote the language, because of course, I don't know. I'm not going to start with bad jokes quite yet. I'll save that for later on. Any other questions so far? All right. Well, if no other questions, then let's keep going and actually make our own smart contract. So to do that, we're just going to come back up here to the contracts folder. And let's say that the distributed app we want to make is something that lets users order products off of the blockchain directly. This is one of the things that makes blockchain technology so interesting, because when you make an API call, you can't send money with that. That would be ridiculous. I don't know if I would trust that even if you could send money with an API call. But with blockchain, you're able to send a payment with your request. And that is where we get into some of those like financial things where one day maybe you could sell your house in 15 minutes just because somebody is able to transfer you the right amount of ether, and you give them the ownership and it's recorded on the blockchain and nobody can ever dispute it or delete it because the blockchain is strong and cannot be broken. But in all seriousness, it's because the blockchain is distributed across a bunch of different computers, and the only way to modify that blockchain is if somebody got 51% control over the network. And that's a problem in the beginning of blockchains. When you're first making one, there is a chance that someone could take 51% control and then they can modify things. But if you're on a well-established blockchain like Ethereum, you don't have to worry about that, because at this point, it would basically be impossible to control all of the computers that have that blockchain data supported. I mean, not supported, sorry, looking at the comments, to have that blockchain data modified. But what extension am I using? That's a great question. I have no idea. I just kind of go with the recommendations that pop up when I use a new file. But this is the one that I'm using in case you wanted to. And then, yeah, the ethereum.org docs and their tutorials are really good if you want to get super detailed into all of the blockchain stuff. Because what we're going to touch here is kind of high level, since we're going through a few different technologies. But let's go ahead and make that new contract. So we're going to call this order maker, because we're going to use it to make orders, and I'm that creative. But I'm going to go ahead and copy. Yeah, I'll probably just copy this. So we'll use this version of Solidity, and we'll make our new contract called order maker. All right, so now that we have our contract like kind of defined, what we're going to do is start off by making a struct for our orders. So to do that, we'll just put struct, if I can type in here, struct order, and we'll say that each order has an item name that's a string. It'll have a price and a quantity. I hate the uint because I always want to type unit, but don't type unit, that is not right. It's uint, and we'll put a quantity. Okay, so we have our first struct defined here in our contract. And basically what this is kind of like an interface with TypeScript. So we're just saying these are the values we expect to be in an order. And now that we have the struct defined, we're going to add a few more variables. So the first thing we'll do is make a kind of like a super order array. And this will keep track of all of the orders that have been submitted to the blockchain. So we'll use our order type, and then we'll make this a private variable, because we don't want everybody on the blockchain to see what everybody else is ordering just because. This is our data. We worked hard for this data, and it's going to be our secret. But now we have this private orders array, and every time an order is added to the blockchain, we're going to push that order to this array. So we have this like master record of everything. Then the next thing we're going to do is actually add a constructor function. So we're going to do constructor. We'll make this public. And I think I got my syntax a little weird there. No, it just looks weird because this is not JavaScript. So one thing to keep in mind, and I'm gonna call this function that we don't have yet, but we'll make that in just a second here. So we're gonna create an order, and we'll pass in, I don't know, I like jalapenos. So we're gonna order some jalapenos. We'll say that one jalapeno is $12 because these are those crazy peppers that were grown in space, and we need 5 of them to make a good salsa. Okay, so of course it's fussing at us because we don't have the create order function defined. And just wanted to say thank y'all for helping each other in the chat, because I'm keeping an eye on it, but I'm like, do I stop and help debug, or do I just keep going? And then somebody pops in with some docs. So shout out to the community for taking care of each other. Appreciate that. Because that means we can go ahead and make this mysterious function that we have in our constructor. So to do that, we're gonna use some wacky syntax again. So we'll have our function, we'll call it create order. It's gonna take a few params. So this is where it gets very smart contracty. The first param that we have is gonna be a string, which no big deal. But then we're gonna read this string from memory. So there's 2 types of storage in a smart contract. And one of them is in memory and the other one is in storage. When you have a variable that's in memory, that means it's only being read in that function execution. It's not something that's being stored on the blockchain long term, like if you were reading it from storage. So one example of something we have in storage would be this orders array. And basically, this orders array, we can read that at any point in our blockchain history, and we'll get the same values regardless of where we're reading it from, if it wasn't private. But here, when we're reading in memory, this is just for like function calls where we want to update something or add a record to the blockchain. So this first parameter will be our item name. And kind of a common convention with smart contracts is to have these parameters have the underscore in front of them. Not sure why, it's just a convention. And you know how we are with conventions, we usually just kind of blindly follow them so that everybody knows what we're talking about. So we have our item name, and then we're gonna go ahead and put a uint for our quantity. And we'll also have another uint for our price.
So is that memory syntax, that's sort of like an opt-in to just make something only available in memory versus stored on the blockchain? I see nothing else. It has something that says like this is stored on the blockchain.
Right, that's kind of like the differentiator. It's like, where is this value coming from? Oh, it's coming from the memory. That way it knows to pull it from like any inputs that are coming in. So when we get to our Dapp front end, it'll know the difference between the value that should be coming into the smart contract versus the values that are already there. Does that make sense?
Makes sense to me, yes. Thank you.
Cool. All right, so now we have our function and the params defined. I'm not sure why this is fussing at me, so I'm going to ignore it for now. And then we're going to use another scope modifier because that is something pretty important in smart contracts. But this internal modifier makes it so that we're able to access this function from our smart contract in here or anything that inherits from this smart contract. So for example, if we, I Oh no, actually I do. Since this modifier is here, if we wanted to inherit this migrations and have some kind of restricted access, we could do that. And that's what these different scope limiters help us do, is determine, can I just call this from another smart contract? Can I only call this within my contract, or can this be called from anywhere? That's what we're using. So now that we have this defined, we are getting a new order with these params, right? The first thing we're going to do is push this new order to our orders array. And we'll do that by making a new order, and we'll pass in, if I can click, maybe, we'll pass in this item name, the quantity, and our price. So we have a new order in our array. And one thing you do have to actually pay attention to now, this is in JavaScript, so make sure you have the semicolon or else you'll get issues later. So we have our orders array update. And now we're going to, let's just set an ID. Because I'm going to do something with this later that will be hopefully interesting, maybe a little useful, maybe spark some ideas. So we have this new ID, and it's just going to be the length of the array because that's good enough for this little app. Now we're going to do something a little interesting. So let's say that we want to make sure we have orders associated by the user that submits them. To do that, we're going to come back up here, and right below our constructor, we're going to add something called a mapping. So we're going to add this mapping, and it's going to take the address, point it to an integer, if I can get the syntax correct. And we're going to call this orders by user. So what we've done here, and let's make it public too, because we might need this for our front end of the Dapp, hint, hint. But what we're doing here is kind of the same as making an object with JavaScript. So this mapping basically says that we're going to have an address for our key, and we're going to have, actually, let me change this to order. So we're going to have an address for our key and an order for the value, which means that key value pair will look something like this, and then the order with the item name, the quantity, and the price. So that's what we're making here with this mapping. And we're going to add one more mapping where we can get an order just by the order ID. And we'll also make this public, and we'll call it orders by ID. So now we have these two mappings. We're gonna actually update this function here. So every time that we have an order, we're going to push this to these different objects. And to do that,
mapping, should it return like an array of orders, or is just a single order on
it'll
the
return,
orders by user?
good question. So it'll return a single order, and you have to access that with the address for that order or with the order ID here. So
Thank you.
very good question. Any other questions?
I was just curious real quick about the memory item name.
Mhm.
So is that meant to mean that we're not gonna publicly disclose the item name? We're just gonna have the quantity and price in the blockchain? Is that what that?
So basically what that's doing is saying we're working with this item name that's in our memory, but we're not storing it to the blockchain. So yes.
Okay, so it just keeps that anonymous or just doesn't reflect that. I see.
Mhm.
But the app will use it. So we'll use it in the app. It just won't save it. Is that?
That's it.
Okay, thank you.
I have a quick question about the address. When you used that example there, is that like a in-memory address, or is that like a blockchain address, like a position on the blockchain?
It's a blockchain address. Yeah, there's a lot of just new little things with the blockchain technology that I don't know, it takes a little while to wrap your head around it because it is so different from APIs or even SOAP operations. So yeah, we're at the beginning of a new world. This is a great time to learn this stuff.
For the address for looking up orders by user ID, as implemented, would this limit the contract to one order per user?
So the way that it would work is, yeah, basically it would be one order per user.
Cool.
And we could have it so that it stores an array of orders per user, but full disclosure, that's a little bit tricky for me right now.
Cool.
Working with data on the blockchain is just so weird.
Cool. Thank you.
No problem. Any other questions or comments? All right, well, if not, let's go ahead and push this new order to both the orders by user and the orders by ID maps. And the way that we'll do that for the address, we'll take orders by user, and we're going to use this message sender value. What this message value holds is the sender address. So whether it's a user on the blockchain or another contract, it's going to have a specific account address associated with it. And that's what we're using for this address for this particular order. And then we'll get the order from our master orders array. And it should just be the ID -1. And that way we don't have to worry about, oh, did we push a new order to the blockchain? Did we do something else weird that we shouldn't do right now? And I'm going to go ahead and copy and paste this line and just update it for our ID. And I'll just put ID in there, and it'll be that same order value. So this gives us a couple of ways that we can access these orders. And if we're looking at something like, I know somebody mentioned earlier, right now, these mappings do just store one order per user. But if we did want to look at which orders are associated with a particular user at the time, we could take this message sender address and do a search on our orders array for any records that have that address. But that is definitely something that we would probably do on the front end, at least right now, because that is a different branch of smart contracts than I've dabbled with at the moment.
Is
But
like all the code inside of Solidity like synchronous, or there's some async thing happening?
It's all synchronous as far as I know.
Okay, so you can guarantee that like your ID -1 will be there on your orders already, basically.
Right. And yes, message is just some global thing in Solidity. It just knows that it's there. It's I want to say it's almost like this, but it is not like this at all. It's just a variable that we know has a certain set of values. So if I look at this, you can see any data we send. So when we get ready to call functions and add things to the blockchain, we have that. You can see our gas, which is if we need to pass any gas to do actions on the blockchain, we'll have to use that. SIG haven't used very much, but value is when we're ready to make a payment for an action on the blockchain. So you create this order and you need to make a payment to get the goods you ordered, right? So we'll be using that in just a bit. But just wanted to throw that out there, just what message is. But other than that, we can actually move on to making this method that lets people order things from our blockchain. This is just an internal thing that updates our array. It updates our mappings so that we have access to something on the front end. And yes, there are so many things to read about blockchain. And that is definitely, like, gas is definitely why we're doing this locally, because you don't want to have to pay for test transactions, right? Right, like that would be a terrible thing to have to do. And there are some free calls to the blockchain, but they're very limited. Like you cannot make any changes to the blockchain. You might be able to read from it depending on how a smart contract is written, but that's really about it. You might be able to read some values. But yeah, so let's talk about that one last function we need to make to, well, get people to pay us for their orders. So we're gonna call this function create order. So creative, right? This time it doesn't have an underscore, but it's gonna take in pretty close to the same values as we did with create order. We're just going to leave out the price.
Is Solidity the only framework for making the apps right now?
No, there's another one called Viper that has pretty good popularity, a decent community, and is maintained pretty well. But Solidity is like the top runner. Did that answer your question?
It's called Fiber.
Fiber? No, Viper. Let me drop that in the chat. I think it's Viper like that, because nobody in tech spells anything right. But again, I digress. So we have this string value that we're going to read from memory, and it's going to be the item name that we're actually receiving from the Dapp. And then we're going to have this integer for our quantity that we receive from the Dapp. The main difference here is that now we will not be getting the price from the Dapp, because we don't want people telling us how much they want to pay for the thing that we're selling them. So we will add another helper function after we get done with this. But this is going to be the heart of what our smart contract does. So we of course want this to be public, because we want people to be able to order from us. And then we're going to put another modifier on this function called payable. So this payable modifier is how we actually allow people to send us money through the blockchain. And yeah, nobody in tech spells anything right. It's great. We can leave out vowels. We can change letters around. If you can mind jumble it, it's a word. But with this payable thing, you cannot execute this function from a Dapp unless you send the right amount of ether. And we're gonna go ahead and define that. So instead of having like some kind of if
These
condition,
modifiers, they're solidity specific, right?
yes,
Thanks.
no problem.
Are they like traits or not necessarily?
Not necessarily like traits, but kind of similar to it. They're just extra things that we put on the function so that the smart contract knows how to interact with the blockchain, if that makes sense. Like it knows what to allow and in which conditions to allow it without us having to write out a whole lot of like code to handle those situations.
Kind of like a decorator-ish.
Yeah. Yeah, you can think of them like kind of like class decorators, but not really, but very much like them. It's, like I said, it's just a weird new world with different syntax and rules. But I highly encourage you to go through the ethereum.org tutorials. Those are incredible. And I am doing a recording of this workshop, so I'll have it posted on YouTube sometime tonight or tomorrow, just in case you want to play it back. But for this, we are going to add a require statement. And this basically tells our smart contract, unless this condition is met, don't do anything else and show a certain message that we set. So for us, we're going to require that whoever or whatever calls this contract and they want to create a function, they have to send us at least this much ether. And ether is just a built-in unit to Solidity. So it's just there. But this tells us, hey, send us this much ether or you can't do anything. But if they do send us that ether, we will actually go ahead and look up the price for the item that they submit. So we'll say that this is the item price. You know, either we can't spell or we're not creative. I don't know which one is worse. They're both double-edged sword. But there's one more, that helper function I was mentioning. We're going to have a lookup helper to determine the price for the items that they submit. And this is going to be the item name. Don't forget that semicolon. And then we'll call the create order. Wow, that was really nice. I haven't had it do that before. I appreciate it when VS Code autofills things in the right way. But yeah, we just make this underscore create order call, and this does all of the heavy lifting of adding everything to the array, to the different mappings. And there are no stupid questions, just want to say that. But using Solidity doesn't require you to use React at all, because using Solidity is just for the smart contract. So this has absolutely nothing to do with the user interface at this point. This is just the code that we're going to deploy to the blockchain, similar to how you would deploy API code to a server. So that's what we're using Solidity for. It's basically our API code that we're putting on the server, which happens to be the blockchain. So now that we have this functionality in place, I'm going to cheat a little bit and copy and paste this helper function, because there's one main thing that I really want to show. Oh, a couple main things. But it's easier to just paste it in because It's a bunch of if-else statements. We all know what if-else statements are. And if you don't, I don't mind explaining those either. But yeah, the require statement does look weird if you've been working with JavaScript for a while. We're not requiring any packages or anything. This time, you just have to do a thing or else you can't finish executing this function. But this is the lookup price function that we were talking about earlier for our payable function that contracts or users call. So we take in the item name, and this is just like a lookup table. So if the item name is one of these options, we return a price. If it's nothing, then we just say it's $5. But there are a few things that I want to cover in here. So we have this new modifier called pure. What this does, oh, yes, I will share that code, sorry. There you go. I put that code in the chat so that you can just copy and paste too. But one of the big differences is we have this pure modifier. And what this means is that a function classified as pure in Solidity does not cost any gas to execute. And when it's pure, that means it doesn't actually change the state of anything on the blockchain, and it doesn't read any of the data from the blockchain. So this is just some generic helper function that we pass a thing in, we need to get a thing out. It doesn't do any blockchain interactions. So it's free for us to use. And this is something else that's a little funky with the Solidity syntax. This is how we define what's returned from our function. And yes, reads are free. Want to throw that out there too. But
so if you don't include that pure, does that make that function like, is it required to do something on the blockchain? Like modify the blockchain, or?
It isn't required to do anything on the blockchain. It's just this pure modifier helps the blockchain know how to handle this function call.
Cool, thank you.
No problem. Any other questions? And yes, rights to the blockchain are what cost gas. And yes, thank y'all again for being so friendly with each other in the chat. I appreciate that because sometimes it's just quiet. Everybody's awkwardly not saying anything and wondering the same stuff. So thanks for the interaction. Where was I? So another weird thing. This is how we define what's returned from a function. So it's just this returns keyword, the type that we return, and some variable name. But this is where things really got interesting, at least to me personally, when I was working with blockchain stuff. When we are trying to compare strings, it doesn't actually have a string comparer. It's just not built into the language, which is why we have this convoluted looking thing here. So this is taking the string, it encodes it to some Solidity smart contract blockchain thing, and that's how you compare strings. That's something that is really weird to me, that Solidity doesn't have string comparison built in. But right now, this is what we're working with. So
is that only a Solidity thing, or is that like a blockchain thing?
I haven't used Viper to know for sure if it's just something in Solidity, but as far as I know, it's just a Solidity thing. Like string comparison isn't supported yet. And it is so weird when you're trying to debug a smart contract and you're like, I'm just trying to compare some strings. Why do I need this much code for something this simple? And the answer is blockchain, because that's the answer to everything now.
Reasons, yes.
That's a good question. When a smart contract's running on the blockchain, who gets paid for running it? So whenever payments are made to the blockchain, those payments go directly to the smart contract. So if you're the smart contract owner, you probably have some permissions. Hopefully you have some permissions that let only you access that like account balance. So you'll need that address, you'll need the key, all that good stuff to access that account balance. But that's where all of the money goes when blockchain methods are executed. And I think it is a way to compare hashes than strings, since there's no string comparison. Yeah. But what else? Yeah, that's just our helper function. A few items on here, and our smart contract is finished. Like, this is it. I know I say that like this wasn't a lot, but this is it for now. Did anybody have any questions on this so far? Do people still try to mine Bitcoin? I always wondered, is that a thing, or did everybody give up?
I think the fact that you could still do transactions means that there are miners, right?
Yeah.
That means there's nodes, right? And that's how they get compensated, is to, you know, do those the compute, and then it's kind of how you mine, and then you get paid out.
I think it's mostly bigger business, the Bitcoin mining stuff. The little people are mining like Ethereum and stuff like that.
Yeah, Solana, Filecoin.
Ah, okay. I was just wondering. I remember I was doing that back in like 2011 and didn't know it any better, and I lost
You shouldn't
my
have stopped.
wallet. I lost my wallet, y'all. I'm
You
so
should've kept-
sad.
You should have kept going.
I should have.
You wouldn't be doing that. You'd just be like, I'm on a beach somewhere.
I would be like
Chilling on my
MySpace
yacht.
Tom. Yeah, I aspire to be like MySpace Tom when I grow up. He just disappeared off the face of the earth, and it's beautiful.
It's great.
I have a question.
Yeah,
How do we deploy this to the blockchain?
that's what we're about to do.
Perfect. Cool.
Just wanted to make sure, were there any other questions about just the smart contract in general? I know this lookup function looks way worse than it is, but just remember the bulk of this is just messy string comparison.
Well, also, you mentioned you had a YouTube. I may have to drop soon, so I was hoping to take a look later if you could post a channel.
Yeah, no problem. I'll have that up there sometime before tomorrow ends.
So are
Okay.
these, sorry, are these prices in Ethereum then? Like 9 and 12?
Yes.
Okay, sounds expensive.
Oh yeah, those space jalapenos, can you imagine what those even taste like? I know I can't, but I'm so curious.
Yeah, because I have 0.05 Ethereum to my name and it's $238.
Yeah, I don't want to know, and yet do want to know how much $12 or 12 ethers, whatever it is, would actually be. Holy crap, that would be
Almost 60
insane.
grand.
That would be crazy. But were there any other questions about the smart contract before we get into deploying it?
So in the real world, if we were writing a smart contract, would we use the oracles to interact with an external system to deliver the goods or service? And then everything else is written in Solidity, but all of our business logic is written outside of Solidity.
Yeah, that's I guess, pretty common workflow at the moment.
Cool. Thank you.
Yeah, no problem. Any other questions?
I have a question. That you said that you define your create order initially as jalapeno costing like $12 or 12 units, right?
Mhm.
But on your lookup function, the if statement returns 9. I just wanted to understand if that's a typo or it's just different values.
Honestly, they're just kind of some
So-
random values. Like the payment to actually do an order is this 0.001 ether, which I think is way more reasonable. But I just put in a price in case, I don't know, it goes to some weird fulfillment somewhere else that uses different currency.
Sorry, what is the difference between the value that is returned on the lookup and the initial value of 12 units that you had on your underscore create order function? Or sorry, on the, yeah, this one, the constructor.
Oh, so right here, we kind of skipped the lookup and just put in the price. So this 12 is actually the quantity. So that's how many jalapenos we're ordering. And then 5 is the price. So we just skipped the lookup step for this constructor function. And the only reason we're doing that is because this is happening in the constructor. We don't want to charge ourselves to make an initial entry to the contract that we're deploying. So that's why we're doing it this way.
Gotcha, thank you.
Does that make sense?
Yeah, I think so. I'll need to read this like quite a few times after the presentation, but yeah.
Okay. But now that we have the smart contract finished, let's get into the fun part. I'm gonna clear out my terminal and we're just gonna deploy this. So the way we do that is very anticlimactic. We're gonna run Truffle Migrate. That's it. And we're done. Now this is on our network and you'll see it deployed the, wait a second, did I not save this? Oh, I didn't make the migration. So we get to see 2 migrations. But since we did migrate that initial contract, let's just look at what happened. And this just migrated to the default blockchain that Ganache has set up. If I switch over and show you what Ganache looks like right now, you'll see that we have, well, ignore that. I think that's just when I started the app. But this is our first block that we've added. So this shows that we added that migration and it's on the blockchain for us to use. So let's jump back into
How did you get that screen?
How did I get this screen? This was just the Ganache app that we installed at the beginning.
So for the Ganache app, sorry, do we just, I'm at the quick start and it says new workspace. Do we just create a new workspace?
Yep, you just make a new workspace. So we've got that. The one thing that I did forget to do is actually add the migration for this smart contract we just wrote, which is fine because we can do that now. So we'll add a new file to the migrations directory called deploy order maker.js. And inside this file, if I make my terminal small, that might help. So in this file, we're just gonna, actually, I'm just gonna copy and paste some stuff. I'll add it to the chat too, so that y'all have it if you're following along. So this is what we're putting in our migration file. And basically, we're importing this order maker artifact from our contract because our contract is the artifact. And then we're just deploying it. This is some fancy stuff that happens because Truffle knows what to do with things. and Solidity handles all of the compilation stuff in the background. And one little secret tidbit down here. I don't know if anybody noticed when we ran that truffle init command, it actually generated this truffle/-config file. And you'll see a lot of comments in here, and it looks a little bit much, but the main things you need to note are your network, which I'll uncomment this since we're doing development things. And this is just the default connection for Ganache. That's all it is here. And then down here, we don't really need to enable anything else. But I just wanted you to see this because this is basically where you can put the specifics for how you want to connect to your network locally on the real EVM or anywhere else that you can. Haven't played with these configs a lot, but I do know when you're ready to deploy it to production, you'll come in here and put the real name of the Ethereum network that you want to connect to, and probably the network ID if there's a specific one. But just wanted to make sure that you're aware of this truffle config file, even though you don't really have to do anything with it. So we have our migration ready. And now if we run Truffle Migrate, I'm going to clear the terminal and actually run that. Now you'll see we have both of those migrations done. So we have our order maker on the blockchain finally, and we can interact with this, well, at least the public parts of it. But one thing I do want to make sure we catch is this contract address. So you can go ahead and minimize the migrations folder and the contracts folder. You can actually close out the smart contract and the migration for now. And what we're going to do is here inside of our source, because we're about to get into the front end of this Dapp, which is pretty exciting. But in the source, we're going to make a new file called config.tsx. And this is where we're going to define our connection to our blockchain, well, our smart contract that's been deployed to the blockchain. So first thing we're going to define here is the address, because that's what we have up on the screen. And we'll just export this. Now we're back home in JavaScript, TypeScript world, and things make sense again. So we can export this constant as order maker address. And this will just be a string equal to the contract address. So the contract address is how we tell the Ethereum network which smart contract we want to interact with. This is like almost kind of like the endpoint that you call for an API. Not 100% like that, but that's the closest similarity that I can think of.
Is that standard for things that interface with the blockchain? You actually have like a blockchain address?
Yes. And then something else that happened when we deployed this contract to the blockchain, this build folder was generated for us. And in this folder, we have the build of our smart contract. And what we want to take out is this ABI. So we're going to copy this array, and ABI stands for application, something with a B interface.
Binary interface.
Binary, thank you. Application binary interface. So we're also going to put this ABI. It's just these, however, 80 something lines. We're going to put this in our config too. And we'll call this, again, I'm gonna be really creative and call it Order Maker ABI. And we'll just paste that array in here. And now we have basically the definition of how we're going to interface with the smart contract from our front end. So thanks for everybody that can make it and have to duck out a little early. I get that. So we have our application binary interface in place. Oh gosh, I need to stop rhyming today. It's a bad thing. But we have this config set up. So now we can actually get into some of the cool stuff that Redwood does. I'm gonna go back to the root directory of the project now, where we should be done in the web directory. So I'm gonna go ahead and clear that out. And we need a new page for how we're gonna interact with our order app. To do that, we're gonna run yarn Redwood generate page, and we'll just call it order. Again, very creative naming today. All right, so now you can see Redwood has made these 3 new files for us in this order directory, order page directory. And if we go in here, we have a test file, which I don't know, I always thought this was something cool Redwood does for you. It generates a test file for you. If you're familiar with Storybook, it makes the Storybook stories for you so you can develop your components and pages in isolation. And if you don't know about Storybook, you should definitely check it out. And then, of course, we have the component itself. There's even some best practice stuff built in, like adding meta tags to your components, which, to be honest, I don't do that very often. But with Redwood, it does it for you so that it's like, I practice Kung Fu, and sometimes when we get a movement wrong, our Sifu comes at us with the stick. He's not actually going to hit us, but it's enough of a threat to where we just immediately get the form right. And I see Redwood doing that in a very similar way. It's like, oh, this best practice thing, don't forget that, because we're going to put it here until you remember. And quick side note on Storybook. It's just like this JavaScript package that lets you develop your components in isolation. So if you're working on a really big app and you need to make components like buttons, drop downs, tables that react to different props, then you'll be able to quickly test those without running your whole app. And then I see somebody had kind of a problem with the network.
Yeah, I think I just solved it. I'm looking in the Ganache, it's set to a different port.
Yep, that's definitely it. Okay, so we have this new page. So I'm gonna go ahead and start up the Redwood server. So yarn Redwood dev is how you do that. And it's gonna start up this backend that we probably won't get into today. But the weird thing about distributed apps is that most of them aren't 100% distributed. Like there's still something somewhere tracking changes to some central database. Just because interactions on the blockchain are expensive, they can take a while, and it can lead to a bad user experience when you have to load everything directly from the blockchain every time. My Truffle config, yeah, let me share that really quick. Let me find that really quick. I think this is the main part that you need. Everything else is just commented out. And
So does Ganesh let you actually deploy to a test network like Rockstein or anything like that?
yeah, that's what Ganache lets you do. It's a test blockchain.
Okay, but can you deploy to like a test net, like instead of mainnet, deploy to a test net like Rockstein or?
Oh, yeah.
Yeah.
You could do that if you just change this host. Yeah, if you change this host value in the ports, and if it does have a network ID, you add that in there and you should be able to connect.
Okay, cool.
And let me, I'm not sure if our ABIs will work the same, just because I've deployed to my network locally, but
Oh, I
I'll
see.
paste it in there just in case it does. Maybe it'll work. No. Okay.
So what exactly is the ABI?
So this just defines everything that was in your smart contract. It
Oh, I
has
see.
the types, whether a function is payable or not, the outputs from it.
So is
Yeah.
this actually like a compiled version of your script? That's what this is? Okay.
Yep, that's exactly what this is.
So do we get this? Do we pull this in? Did this file get created somewhere for us then when we migrated, or?
Yeah, when we ran the migration, Truffle created this build
Oh,
directory,
okay.
and that's where we get the ABI from.
Oh, okay, awesome.
But you pasted this part, right? This was pasted by you. Yeah.
I'm not sure why it's not letting me paste this in the chat this time. But it's definitely not letting me paste that in. I don't know why. But again, I'll have to get repo up for this a little bit later after the workshop is finished too.
So when we ran migrate, so that compiles the script and then also does put it on our Ganache blockchain locally?
Right, that's
so
correct.
So then why do we have to copy the ABI?
This is just so that we can work with the Web3 package we'll be using. And it needs the address and the ABI to determine which functions we have access to and which variables that we have access to.
Okay.
So I want to say, is there an API equivalent to anything like that? Maybe you can think of it like if you were doing calls in Postman, and you know how you have the documentation for the different parameters that need to be passed to an endpoint. It's kind of like that.
Okay. So we just paste that whole block right into the array that's the ABI.
Right. So
okay.
It's just the ABI because I made the mistake of just copying this whole file. It's not right.
Wow, yeah, it's like 10,000 lines.
Yeah, don't do that.
Okay.
Just this ABI value right here.
Okay, gotcha. Thank you.
No problem. Okay, any other questions? All right, if not, then let's actually start building the front end of this thing, right? So first thing I'm gonna do is just honestly get rid of most of these imports. And we're gonna need the use effect hook, and we're gonna need use state. So we'll just get those from React. And then we'll also need to import Web3 from the Web3 package we installed toward the beginning. So something else that we'll need to import will be the, where'd that config file go? We'll need this order maker address, and we'll need this order maker ABI. And these will come from, let's see if I can get the directory right the first time. Yes, there's the config. cool. So we have everything we need to set up the connection for our Dapp. But of course, I'm gonna make you wait a little bit before we get to that. And we're gonna completely just gut out this component to where all we have left is this. And we'll start by making some state variables because those are always super exciting. We're gonna have an account that's going to hold our account ID for whoever's interacting with this blockchain at the moment. And this is just gonna be a string. So I'll set that to an empty string. And then we'll also need a state to track the order that we want to display. So we'll get that. We'll just set it to null for now. And the last thing that we'll need is the instance of our order maker. And this will make more sense once we actually call the blockchain and get everything. So we're going to set order maker to null as well. Okay, so we have our states defined, and then this is where we get to have a little bit of fun. We're going to make an instance of Web3 connected to our local Ganache network. And the way that we'll do that is just by instantiating a new instance of this Web3 object that is connected to that particular local host address. So this is localhost, I think 7545. All right. So now we have an instance of Web3 that's connected to our local blockchain. And Web3 is a pretty standard library that's used in dApps so that we can interact with the blockchain from the front end with a React app, a vanilla JS app, because that would be something crazy, right? Not using a front end framework, but we have that in place. So now let's define a function that's gonna load in the data we need from the blockchain. To do that, we're gonna call this load data. And gonna make an arrow function where we get the accounts from the Ethereum network. So this is actually going to be an async function. And we're gonna call this accounts. And we'll set this equal to an await where we get the Web3 instance we're connected to. We'll get the Ethereum network and we'll list all of the accounts that are present. So actually, let me do get accounts. That way we have all of the account addresses. So the way we'll determine which one is the current user, we'll set account to accounts 0. So we'll just get the first account from the blockchain and we'll say that is our current user. You could get fancy here and have some kind of validation around which one you want to pull, or maybe you know the particular account that you need to be working with. But just for this little workshop, we're just going to pull that first account ID. So the next thing.
Would that get accounts call get all the accounts on the entire Ethereum blockchain? So like, since this is a demo, that's not a problem. But like if this was a production sort of thing, wouldn't that like crash or something? It seems like a lot.
Yeah, there's a good chance. If you have a bunch of different blocks on your network, you probably don't want to get all of them. unless you do for some reason. But yeah, in production, you most likely wouldn't want to fetch all of the accounts that are on. But this get accounts command, it just returns an array of strings. So it might not be that bad if you needed to do something with all of the accounts.
Okay.
Just depends on how many you have in your
Yeah.
blockchain.
Thanks.
Yeah, no problem. So the next thing we'll do is actually make our order maker. So we'll have a new Web3 thing, and it'll be ETH contract. And this is where we get to pass in those values that we defined up here in our config file. So I'm just gonna actually copy and paste these two and bloop them right in there. Let me see. I think I need to reverse the order on these. Yep. So we have our ABI that's passed in, and we have this address, and then this call creates that connection to this specific smart contract on our blockchain. So does that make sense? This is how we actually make the connection to our particular smart contract. This instance up here connects us to the blockchain, and this down here connects us to the smart contract. So now that we have that, we can go ahead and set our order maker state to order maker. And the last thing that we're going to do in this function is actually get the first order off of the blockchain. So to do that, this will just be const order. And this is where the call to our order maker actually comes in. So this will be asynchronous because we're pulling it from the blockchain, which means we're probably going to wait a while. And we'll get the order maker dot methods dot orders, and right now, actually, orders by ID. Orders by ID, because our orders array is private, so we can't call that from here. And yes, the reason that I'm storing that as a state is because I'm gonna use that order maker in a different function call a little bit later. But right now, oh yeah.
Yeah, thanks.
No problem. So right now we'll pass in this ID of 1, and we'll call this method from the blockchain. And this is just the Web3 syntax. Like, we get all of the methods from our contract, which are defined in this ABI. And then when we call it, that's actually making a request to the blockchain. So we'll go ahead and set our order. And that's it for this function. So we are finally done getting all of our data from the blockchain. Any questions about what we did here?
I just had a question about so we're getting the account, the very first account, and we're getting the very first order. Are these just random things just to try it out, or would?
Yeah, these are pretty much just random things to try it out, because in a production blockchain, you probably have some kind of, maybe some seed data or some kind of initial condition that you would start the contract off with. And maybe you wouldn't even be making a Dapp with the smart contract. So you wouldn't need to have an initial order on the blockchain or something to reference. And as far as choosing accounts, that's something that would definitely be pulled more from the business logic. So you know, well, this set of accounts, I need to update the orders, or a different account, I need to pull this down so that we can send an invoice to a customer or something like that. Because most of
so this is the person,
Mhm.
so this is the person buying the jalapenos is
Yes.
the account. Okay, all right.
Yeah, the person buying the jalapenos is
And
the
then
account.
who's the other end of the transaction? That's the address?
The other end of the transaction is the smart contract. So the way that it works is this front end we're building, the account that we get from the user is for the customer. And when we make the order request, that goes to the smart contract address, because the smart contract is technically the owner for all of the orders.
Hence the smart contract that's doing work on our behalf or on the other person's behalf or the, right.
Right. That's the whole distributed thing, because technically no one owns the smart contract. If there's any updates to the smart contract, it has to be redeployed, but the old one is never overwritten. So it always exists. That way, like, I can't go into this smart contract and update it and be like, oh, well, these changes were always there. So that's part of how that decentralization is baked into the blockchain tech. The smart contract is its own entity.
So does that mean you can never make any mistakes? Because if you have a bug in there, and your
Yeah.
smart contract's out there and you're sending it to the wrong address, then you're kind of out of luck.
Yep.
Yeah, it makes testing a whole lot more serious.
Yeah, it does. Because once you deploy the smart contract, you can't roll it back. You can't do reverts. All you can do is deploy another smart contract. So testing is super important with blockchain development, because once it's on the blockchain, nobody can modify it. It's what makes it such an interesting technology. I don't think it's the answer to the world's problems, but it is interesting to work with. But were there any other questions about just this front end part so far?
So I kind of have a question. Like what's stopping you from just having like your own internal account information and then saying, you know, customer B has this Ethereum account in my own like internal, like my own database, and then querying off of that API, querying off of my API into Ethereum instead of querying Ethereum directly? Or are we trying to use blockchain for everything?
Absolutely nothing is stopping you from that. That's kind of what I was trying to talk about when I mentioned like a lot of decentralized apps aren't actually fully decentralized, because sometimes you do need to store some of this blockchain info on an API that you control, just because those requests to the blockchain can be expensive, and maybe not with gas, but sometimes blockchain requests are just slow. So it's totally normal to have an API backing up a blockchain thing. Right now, there's nothing that's completely distributed.
Yeah, okay. And like, what's the reliability of a transaction being validated? That's kind of more of a general question, I guess. But does that make sense? Like, could it fail? Could like a mine of someone that's mining? I guess there's like thousands of people mining, but could a transaction fail? And
I think theoretically it could, but typically it won't. All that will happen is that the block will get added, and then that change will ripple through the rest of the network and update everybody's machine. So there's not really a race condition type thing that happens with blockchain. Everybody just has to wait until that block is added. That's why sometimes the requests to and from the blockchain can take so long, because if there are a lot of blocks being processed at the time, yours is just in line waiting. Oh yeah, and if you use the wrong params. So if you don't send enough gas, it's definitely not gonna let you execute your command. If you don't send enough ether, it's not gonna let you finish your transaction. And if any of the methods that you're trying to hit have requirements around them and you don't meet them, it will also reject your transaction.
Okay. Yeah, I just learned about gas today. That's a new word. I mean, I understood the concept that it takes computation and power, but I didn't know that there was a colloquial term for it all.
Yeah. Yeah, no problem. Okay, so we have this load data function good to go. Now we're going to call it as soon as this component loads. So this is where our use effect hook is going to come into play. And what am I doing? Sorry, had a brain fart for a second there. So we'll call this use effect hook and we'll load our data when the component is first loaded. That is why we add this empty array here, because if you don't, you get stuck in an infinite loop of loading. And I promise you, you don't want to be there because it crashes everything. But we're loading all of this data. All that we have left to do, just a couple more things and we'll be done, I promise. So first thing we'll do is finish up the functions we need to make. And we know for sure that we're gonna make something to create an order, right? So to do that, we're gonna pass in an event because we're gonna get this when we submit a form. Wait a second, what did I, okay. I believe this is gonna need to be async because we're working with the blockchain. Then we'll go ahead and do an event prevent default. I'm trying to remember my words here because we don't want that page to reload when we submit so that we don't lose those values. And then I'm gonna do some copy paste here because we're just gonna get the values out of our form. I just posted that in the chat if you're following along with me. And the next thing we'll do is actually call our blockchain method. So we are going to use await. And this is the reason why we had to set that order maker state, because we need it inside this other function. And we'll get the methods and we're gonna call create order. And then we're gonna pass in the two values. So we have our item name dot value, because it's gonna get mad if I don't do that dot value because we're getting it from a form. And we'll do the same with the quantity. Whoop. And then this is where it gets blockchainy. So now we need to send this request to the blockchain. And there are a few things that we need to pass in. So we'll make an array. And the first thing we'll send is which account this is coming from. So this is where that account state is getting used now. Then we'll need to send some amount of gas, just because we're finally executing this from outside of the blockchain. So we got to send some gas or else this command won't get executed. So I'm just going to put in some number because thankfully we aren't using real gas. And lastly, we need to send a value, because if you remember in our smart contract, if I go back here, where is that? remember we made this payable. Where is it? This is payable. And if we don't send this ether, we can't execute this function. So we're gonna go ahead and do that by passing value. And this is gonna be equal to some fun Web3 stuff. So we're gonna do web3.utils.toWay. And the reason we do .toWay, because this is the smallest amount of ether that we can send, I believe. This is one of those things where it's like, I am still, yes, you can overpay ETH. I hope that you don't, but you definitely can. But yeah. So we're just gonna pretend that we have this ether and just send it in there because this is not a real network, so it's fine. That is everything that we need to execute this smart contract function and add an order to the blockchain. So now all that's left is to actually make a UI that people can interact with. But any questions about this part so far?
Yeah, I was just wondering where the send method is coming from, because when we made the create order method, I didn't see send on there. Is that just like generated when you create the smart contract?
Yep, it's just generated. And this might also just be some Web3 syntax, because there is a difference when you make a call to just read some data. Up here, you just call the method. And when you need to actually execute something that makes a change on the blockchain, you have to use the send method, or else it causes some errors when you're interacting with that blockchain.
Cool, thanks.
Yeah, no problem. Anything else? I know this is always funny when I'm asking for questions. I feel like Dora, where it's like, what do you think about this? That's right. Okay, we can go ahead and move on then. So the last part we actually have to do is just some simple HTML. So this is one of those cases. I'm definitely gonna cheat and do a copy and paste, but I'm gonna put that in the chat because now it lets me put code in the chat. That doesn't make any sense to me, but hey, it's code. And then it didn't even put the whole thing. Or maybe it did. I don't know what it did, but it looks like it copied the main part. So one thing, make sure you do, if you are just copying and pasting that code, it left out the return up here for some reason. So make sure that you add that. But I'll just do a little walkthrough of what's happening for our user. So if we have an order set, we're gonna show this order information. And then we have a form where they can submit any orders that they want to. So now if I switch over to my browser, if I can find the right button. It's always so much fun trying to switch screens. Okay, can y'all see my browser now or no?
Just your VS Code.
Okay. Please don't tell me I'm having tech problems.
I think in Zoom you can choose to share like a window or a screen. Looks like you're just sharing your VS Code window.
Can you see my browser now? Or still VS Code?
just VS Code. There we go. That worked.
Okay. So I think I'm in the right browser. Let me make, oh, nope, this is not the right one. Okay. I want it to be that one, but it's not even open. Sorry, y'all. There would be one hang up at the very end, huh? I guess while I'm trying to figure out this weird thing that's happening with my computer, did anybody have just any like Dapp or blockchain questions in general?
Kind of a general question about dApps. So I kind of see how the API is kind of distributed on the blockchain, but for the front end, is that sort of a more traditional, like just, have some JavaScript run in the browser or just access a web server folder or something like that?
Yep. So the front end for a Dapp is no different than the front end for any other app, which is actually kind of surprising at first, but the only difference is instead of calling an API, you call that Web3 object.
Gotcha. Interesting.
Yeah. Any other questions while I figure out what the heck is wrong with my computer? Ooh. So my first Dapp job was actually just a contract position because they, oh, wait, did y'all see something pop up in the browser? Please say yes.
Yep, just saw a
Okay.
tab open.
Good.
Oh my foot.
But yeah, there aren't like a lot of people with super experience with blockchain development because it hasn't been a thing for that long. It's just the best way to get started is just make a few dApps and start learning the jargon, start learning the tools. I swear it's not as mysterious as people want to make it seem. It's just another tool. Like, it's nothing that crazy. Let's see. Hey, we're actually reading something from the blockchain. That's crazy. So if you remember in our constructor for the smart contract, we had this initial order that we had with the jalapenos. I guess I think I have my labels switched around, but yeah, let me actually go ahead and fix those labels.
Can we see the front end?
The front end code?
Yeah, the front end code.
Yeah, let me switch back over. Hopefully it doesn't break this time. Okay, can you see VS Code? But yeah, this is actually it. Like, I know that's a bit of a sharp drop off, but we're kind of done. One thing I do want to show is what happens when we add in order to the blockchain. So this time, let's say I want to get some feta because I don't know, what can you do with feta and jalapenos? We would find out. So I'm gonna get whatever 3 units of feta are. Nothing's gonna change on the screen, but what I'm gonna do is show you if I come back over here in VS Code and change, wait a second, where's that? Oh, here, yeah. If I change this ID to 2, we should get a new order on our screen. So if I switch back over, either that new order is going to be there or I'm gonna be a little sad. Hey, it's actually there. Okay, no need for sadness. So I guess Feta was just super expensive in my eyes. It's 12 currency whatevers, and it's been submitted to the blockchain. So if we look over here in Ganache, you can see this other block that's been added just about a minute ago. And you'll see the gas that we used, what's packed in this transaction. We had a contract call, and this is generally the information that you can see if you look at a raw blockchain. But this is actually it. I just wanted to show y'all how to make a smart contract, talk through some of that jargon, and see that a Dapp is actually just a regular React app, but with a blockchain for a backend instead of an API. So did y'all have any questions or comments or anything that I could have done better?
Did you finish that story about your first decentralized app job?
Oh, so basically it was to work with something kind of like this, but on a much more complicated scale. They were doing some kind of finance application, and you had to send these different transactions to different accounts. It was hard, to say the least. Like, the documentation for Solidity is there, but it's a little hard to parse through at the moment. And then you have to be really careful with which versions of Solidity that you're using, because that can change the compilation that you need to use for like Truffle, or if you're working with an Oracle. But really, it's like right now, it seems like the companies kind of know that Ethereum development is very new. So they're willing to be flexible with you learning on the job.
That's cool. Okay.
Is there any type of authentication that the blockchain needs? It looks like you just used this library to just pass an object, and in the test environment, it just sort of lets it go through. But in production, as long as something's connected to the chain and throwing good parameters at you, is it just let everything go?
Pretty much. If you want to do some kind of like authentication or validation around a user, that's when you would start getting into more complex require statements in your smart contract. That's where you're going to handle everything like that.
Interesting.
Any other questions or comments or things?
Yeah, Militia, I was wondering if you have any suggestions on tools to use to look at existing smart contracts to help understand how things work. So like, looking at like OpenSea's contract, or, a Uniswap or a Sushi contract, to try to understand like how some of these DeFi things work. A lot of times I look at them and it's like a big, a big bunch of binary. But I was wondering if there's any tools you have in your experience.
Not in particular, honestly. The blockchain stuff is still pretty new, so there's not a whole lot to make it super developer friendly. So really, if you don't have access to that smart contract before it's deployed, it's
You're talking about having to reverse engineer it, sort of thing, like uncompiled.
Yeah.
Oh, okay, yeah.
Yeah, because like, one of the super handy things you can do with like React or with JavaScript is like go to someone's site and look at the actual code. And with minified or obfuscated code, you can at least derive the AST from it, right? And start to match that up to be like, okay, like this is probably React here. I can ignore that. And then you can actually start to get to interesting things. But I was just wondering if there are any tools that you came across in your experience that helped you understand what other people were doing.
Not in particular. Like, the most I've been able to glean from a smart contract might be some parameters that you pass to it, but the actual code behind it, I haven't had any personal luck.
It seems to me like this